This is number 29 on page 139, and I'm graphing this system of linear inequalities. So I have two equations, both in standard form, so I'm going to put them both into slope-intercept form. And I'm not going to go through the whole process with that, but I know that the slope of this line is the opposite of 3 over 2. So I'm going to have y, and nothing's going to change signs here. Y is less than or equal to negative 3/2 x plus 6 divided by 2, 3. So if you go through the process, that's the equation, or the inequality of that in slope-intercept form. So I'm going to graph the boundary line, which is going to be solid on that because this is a less than or equal to. So the points on the line will be included in this solution. So this is a downward slope, y-intercept of positive 3, downward slope of 3 over 2. So I'm going to rise negative 3 and run 2, rise negative 3 and run 2. And so there's the boundary line on that. And I'm going to use my pencil. This is a less than or equal to, and I'm going to shade below it then. And so I'm going to shade all of this area, this entire half plane. And I'm going to test 0, 0, and that's really easy to do here. If I just put in a 0 for x and a 0 for y, the ordered pair 0, 0, into the original, I have 0 is less than or equal to 6, which is true. So I know I've shaded the right region. So then I'm going to take this next equation and put this in slope-intercept form. And when I do this, I will have y is greater than or equal to the opposite of 2 over 3, so negative 2/3 x plus 6 divided by 3 plus 2. So you can go through the whole process to get that one into slope-intercept form. So I'm at positive 2, and I have a slope of negative 2/3. So I rise negative 2, run 3, rise negative 2, run 3. And that is also a solid line. So, whoops, rise negative 2, run 3. Oh, there I am. Okay. Okay, now, on that line I just graphed, which is this line, I'm going to label that. This is y equals negative 2/3 x plus 2, the boundary line, and this one was y equals negative 3/2 x plus 3, that boundary line. So with this one, I'm above that line. So I'm on this, I'm going to shade above it. So I'll do that with a shading in an opposite direction. And I can see that the area where I'm overlapping both is right in here. So that's where my solution range will be. So I'm going to want to pick a point in there and make sure it makes both inequalities true. So let's go with negative 2, positive 4. That's clearly in the shaded area. So if I plug into this equation, a negative 2 for x, so I'm going to do that over to the side. Into that inequality. 3 times negative 2 plus 2 times 4, is that less than or equal to 6? So this is negative 6 plus 6, is that less than or equal to 6? 0 is less than or equal to 6, so that works in the first inequality. Now I'm going to plug it into the original second inequality. 2x, so 2 times negative 2 plus 3y is greater than or equal to 6. So I get negative 4 plus 12 is greater than or equal to 6. 8 is greater than or equal to 6, also true. So I know that I've shaded the correct boundary. In that picture, that's the only way you can show this solution. That is the part of the plane that it has an infinite number of points in it that will make this inequality true.